We continue Unit 6, Solving Systems of Equations with Word Problems. We begin by setting up our equations. Miss Friendly's Cookie Store sells 3 types of cookies: chocolate chip for $1.45, oatmeal for $1.30, and sugar for $1.20. On Saturday, she sold 135 cookies. She sold 2 more than 3 times the number of chocolate chip cookies than she did oatmeal cookies. So we want to know if she sold $183.75 worth of cookies, how many of each type did she sell? To begin, let's identify our variables. Let's let chocolate chip cookies be C, oatmeal be M, and let's let sugar cookies be represented by the letter S. To set up an equation, a regular two-system equation, we look at number equals a total number, or money equals a total number of money. In this case, I have 3 different equations, though, and 3 different variables. I do know that I have a total sold of 135 cookies. So this can still be represented by number equals a number. The total number of chocolate chip cookies plus the total number of oatmeal cookies plus the total number of sugar cookies is equal to 135 cookies. Look for your equations in the sentences. This sentence right here holds one of the equations. She sold 2 more than, so that's going to be plus 2, 3 times the number of chocolate chip cookies than she did oatmeal cookies. The third sentence holds the money equals money. Well, it says here that the chocolate chip cookies were $1.45 plus the oatmeal cookies were $1.30 plus the sugar cookies were $1.20. So I have to multiply the cost by the number of cookies for each type of cookie. And then that's equal to the total dollar amount, $183.75. Now I have the 3 equations, so I just need to solve. I can see that the second equation is already solved for C. I could substitute C in for equation 1. Getting rid of the parentheses, we have 3m plus 2 plus m plus s is equal to 135. 3m and 1m plus 2 plus s is equal to 135. Bring the 2 over to the right-hand side by subtracting 2 from both sides. And we get 4m plus s is equal to 133. By substituting c into the top equation, I now have gotten a new equation. 4m plus s is equal to 133 by eliminating c. So if I take c and I plug it into the third equation, I will eliminate c out of that equation and I can put it over here in the second column. So the second and third equation is what I'm going to use next over here. So let's substitute c in for equation 3. Substituting c in for equation 3 now, we get $1.45 times 3m plus 2 plus $1.30m plus $1.20s is equal to $183.75. Let's multiply and distribute. $1.45 times 3m is $4.35 times m. $1.45 times 2 is $2.90. Now I've successfully gotten rid of my c, and I'm going to end up with something again like the 4m plus s. Combine like terms, $4.35 plus $1.30 is equal to $5.65 plus $1.20s is equal to, when we subtract $2.90 from both sides. Now I have 2 equations that have two variables, and this is easier to solve. So $5.65M plus $1.20S is equal to $1.85. Line the variables up so we could see what's going on. And I could see that if I multiply the top equation by a negative $1.20, that would allow me to eliminate the S's, the sugar cookies. We get negative 480 M minus $1.20 S is equal to negative 159 and 60. Let's rewrite the bottom equation because we didn't change it. Now let's combine terms. The S's will now go away, and 565 minus 480 is 85 cents. So 0.85 M is equal to 180 minus 159 is 21.25. Dividing both sides by 0.85, and we get M is equal to 25. Let's substitute M back into the second equation, and we end up with C equals 3 times 25 plus 2. So C is equal to 75 plus 2. C is equal to 77. So now we have M and C. Now we just need to find S, so let's substitute this back into the first equation. So the first equation was C plus M plus S is equal to 135. C is 77. M is 25. 77 plus 25 is 102. Bring 102 to the other side and subtract, and S is equal to 33. They sold 77 chocolate chip cookies, 25 oatmeal cookies, and 33 sugar cookies. Next word problem. Devin bought 3 Hershey's bars, 4 Snickers, and 7 Butterfingers for $12.51. Sammy bought 5 Hershey bars, 2 Snickers, and 1 Butterfinger for $6.67. If Snickers are 10 cents more expensive than Hershey bars, how much does each bar cost? First, we need to identify our variables. So let's let H be equal to Hershey, S be equal to Snickers, and B be equal to Butterfingers. Let's find our equations. Notice in the first sentence, I have an equation. 3 Hershey's plus 4 Snickers plus 7 Butterfingers is equal to $12.51. The next sentence holds the next equation. Sammy bought 5 Hershey bars plus 2 Snickers plus 1 Butterfinger for $6.67. The last equation is in the last sentence. Snickers are 10 cents more expensive than the Hershey bars. So Hershey plus 10 cents. Now I have 3 equations I can begin by solving. And I'm going to substitute, because I already know what Snickers is. It's H plus 10 cents. So I'm going to substitute it into the top equation, and I can substitute it into the bottom equation. So in the top equation we have 3H plus 4. We're substituting H plus 10 cents into the top equation, plus 7B is equal to $12.51. Let's clean this up, and we get 3H plus, that's 4 times H is 4H, 4 times 10 cents is 40 cents, plus 7B equals $12.51. Combine like terms, 3H plus 4H is 7H, plus 40 cents plus 7B is equal to $12.51. Subtract 40 from both sides, and 7H plus 7B is equal to $12.11. I need another equation that's going to give me H and B, and I notice that if I substitute S into the second equation, that will also give me h and b. So I'm just going to rewrite the second equation. Substitute in for s again. Distribute 2 through the parentheses. 5h plus 2h plus 20 cents plus 1b equals $6.67. Combine like terms, the 5h and 2h give me 7h plus 20 cents plus 1b equals $6.67. Subtracting 20 cents from both sides, and 7h plus 1b is equal to $6.47. So I have right now the two equations that I will use to eliminate another variable. Now I'm going to eliminate one of the letters, and I think it would be easiest to eliminate h because all I need to do is multiply one of the equations by a negative. So I'm going to multiply the bottom equation by a negative. So we get 7h plus 7b equals 1211, just rewriting the top one. Negative 7h minus 1b equals negative $6.47. The 7's go away, and that leaves me 6b is equal to 564. And when we divide both sides by 6, then we get b is equal to 94 cents. Now that we have b, let's substitute it into one of the new equations that I found and solve for h. Let's plug this into the second equation. So we have 7h plus 1 times b was 94 cents is equal to 647. Subtract 94 cents from both sides, and 7h is equal to $5.53, so h is equal to 79 cents. Now I have the cost of the Butterfinger and the cost of the Hershey bar. Still need the cost of the Snicker. Equation 3 was the Snickers is the Hershey's plus 0.10 cents. So the Snickers is equal to 79 cents plus 10 cents. So Snickers is equal to 89 cents. So this is a word problem, so it has a word solution. A Hershey bar costs 79 cents, a Snickers costs 89 cents, and a Butterfinger costs 94 cents. And this completes the last flap of your foldable.